together from all over the country. They are selected on the basis of the ideas that they submit. Not that they have to work on the same idea, but nevertheless, it shows us their empathy, their commitment to inclusive innovation. And then Professor Ramgopal Rao, IT Director, inaugurated the course, and several colleagues have already lectured to them, including Dr. Chakrabarti Chakku from IDC, Dr. Ramgopal Rao, Dr. Madhusudan Rao from IT Delhi, Chintan Vaishnav, formerly of MIT and now Atal Innovation Mission, and a few others. Professor Ramkumar will join in the afternoon. So the purpose of the course is, as you know, to sensitize the young students to take real life problems of the society and solve them. Dear friends, Professor Amaresh Chakrabarti is chair of the Center for Product Development and Manufacturing at Indian University of Sciences, Bangalore. He's a very dear friend and has pursued many interesting projects, including some with the grassroots innovators. So several of his students worked with the grassroots innovators, tried to improve their design, improve their functionality. He has published very widely. He organized conferences, international conferences on the design and development and inclusivity. So he's a very accomplished scholar, but the best part of his career, to my mind, is his deep interest in social transformation of our country and worldwide. So Amaresh, here you are. Welcome.
Okay, thank you very much, Professor Anil Gupta. It's always an honor to present in your forum, and it's good to see so many students from various walks of life and institutions. Okay, so I will share my screen. And just tell me when you are able to see it full screen. I'm still.
Yeah, it's full now. It's good. It's good.
Okay. Okay. Thank you. All right. So I will start with my favorite story on Genesis space probe. This is a space probe that was designed by the NASA. And it was launched in August 2001 in order to collect particles from the solar wind. Okay, so in order to collect those particles, it has to go much closer to the sun. So it had to travel 1.6 million kilometers from the Earth. And this was a very important and, of course, quite expensive mission and a very time-consuming one. So in order to make sure that nothing fails on its way back, the designers had planned for launching two parachutes. Okay, two parachutes, because the probability of failure of both the parachutes at the same time is pretty small. So the idea was that as it re-enters the Earth's atmosphere and slows down, this will trigger the opening of two parachutes, and it will be hanging in midair until a helicopter or some other vehicle comes and picks it up, so that there was no chance of it hitting the ground and getting spoiled. Okay, so fast forwarding 3 years up, and this is 8th of September 2004, and the space probe has entered Earth's atmosphere and it hits the ground. And obviously, this caused a lot of heartburn. Committees were formed. They looked at all the causes of why this happened after so much precautions were taken. And this is what was found, that it failed because of back-to-front switches that were meant to sense the deceleration and then open the parachutes. The cost was $250 million US dollars, and of course the many years of effort that it caused. And the most likely reason for the accident was that the engineers had been misled by the faulty design. because the manufacturers could show that on the engineering drawing, they followed exactly as specified on the drawings, and therefore the fault was a design fault. So what do we learn from it? First of all, the design is complex. We are talking about one of the top organizations in the world for making complex devices with a long prior experience, and yet this happened. The second is that design is important, even if you look at it purely from the amount of money and the effort that has gone into doing it. But the most important part that I would like to submit to you is that design is actually fun. And this doesn't come from the story of the Genesis space probe. But it does come from elsewhere. And so in order to see elsewhere, what was done at some point was that we looked at the lives of outstanding engineers and innovators. Now, who is outstanding? You can have a subjective debate about it. So it took fairly non-controversial names, and I'll place it in a second to you. First was Archimedes of Greece. He was actually more known for his mathematical engineering prowess than his mathematical genius at the time of the antiquity. Okay, he was for building means of burning enemy ships and creating all kinds of other devices. The second is Leonardo da Vinci. I think you have heard of him. He was an Italian polymath, gave the design for a helicopter, including, of course, also drew brilliantly well. Mona Lisa is probably the most well-known of his paintings, and so on. Third is James Watt from the UK. He was a Scottish engineer, and contrary to popular beliefs, he did not invent steam engine. He invented an improvement of an existing steam engine that was designed by Newcomen about 50 years before. So much so that it became efficient enough that large companies could buy it and run their machines, which was a major factor that led to the industrial revolution of the first industrial revolution. Isambard Kingdom Brunel, voted the greatest engineer from Britain ever. He was a railway engineer, and he designed the first transatlantic steamship. I think you have not heard of it, which is a bit of a pity. But I would like you to look up the Google for I.K. Brunel. He designed, among various beautiful and efficient firsts, the transatlantic steamship, the first transatlantic steamship that, of course, as the name implies, went from Europe to North America. Of course, he was faced with a lot of difficulty in getting the approval and raising money for this, because nobody believed him. This happens when you are coming up with ideas that are quite novel and people are not familiar with it, and of course they don't believe it. And what was his idea? His idea was, in retrospect, very simple, that he would make a very large vessel. He'll make a large ship, and he will push that through the waters in order to take it from the coasts of Britain to the coasts of America. And he would do that without stopping over anywhere for taking additional coal, right? So it would be a one-hop steamship. Now, what was so novel about this idea? Because nobody has done it, right? They would always go from one port to another, fill it out with additional fuel, and move on. Why would they do that? Because, of course, they made ships that were much smaller. Why did they make ships that were smaller? Because they wanted to reduce what is called drag, right? For those who are engineers, would know the name drag, right? Drag is the friction that you feel a body feels when it is moved through a fluid such as air or water. Now, so it is the fluid friction, right? Now, everybody knows that the larger the surface area, the more is the drag, and therefore they wanted to minimize the surface area. That's why you see that our boats usually have a very pointed end, right? Very pointed end, because in some sense you reduce the surface area that is in contact or against the waters, right? Now, what of course baffled everyone was that somewhat Kingdom Brunel was saying just the opposite. And of course, people laughed at it, right? So then Brunel said the following. He said, let's look at it, right? You are absolutely right. In order to reduce drag, we need to reduce area in contact with the water. But then on the other hand, let's look at what it is that overcomes the drag. The drag is overcome by the engine, right? That pushes the ship through the water. Now, where does the engine get its energy from? Well, of course, those days it would be coal. So it is the amount of coal that amounts to the amount of energy that you are carrying, and it is the surface area that amounts to the amount of fluid friction that you are going to encounter. Right. Now, of course, the amount of coal has to win over the amount of fluid friction, drag. So since drag is proportional to the surface area, and what is amount of coal proportional to? It is proportional to the volume of the ship, right? So volume, roughly speaking, will determine the amount of coal that you are going to be able to carry, and therefore do not require refilling. And drag is going to be proportional to the surface area. Now, if I take a simple shape, just to illustrate the point, a sphere, the volume is 4/3 pi r cube, right? And the surface area is 4 pi r square. So if I make a ratio of the volume of the sphere to the area of the sphere, what we get is 4/3 pi r cube divided by 4 pi r square, and that's 1/3 r. Or in other words, the volume to surface area ratio is proportional to the dimension, the linear dimension of the object. In other words, as I increase the size of the object, the linear dimensions, the volume will increase faster than surface area. In other words, the larger the object, the more its effective volume is with respect to its area, and therefore the more capable it would be in carrying more coal than the fluid friction that it has to encounter. In other words, the bigger the better if you want to build a transatlantic steamship. This is something that we can calculate now with, at best, first year or physics, right? But of course, it was a brilliant and very unintuitive for the day argument. And of course, he eventually got the money and built the steamship. And not surprisingly, he managed to reach the coasts of America with spare coal in the ship. Right, so that's somewhat Kingdom Brunel. Look it up. Alexander Gustave Eiffel, or Eiffel as English would call it, a French railway engineer. Eiffel Tower, of course, was one of his great designs. Thomas Alva Edison, everybody knows. Again, not the inventor of light bulb, but an efficient light bulb that was adequately efficient that it could be commercialized, and it can stay for a reasonable period of time that anybody would be interested in buying it. Alexander Graham Bell, Scottish inventor, of course, inventor of the telephone. Nikola Tesla from Serbia, Serbian engineer, of course, those days not Serbia. Induction motor and various others. Induction motor probably the most widespread application of his design. Just once again. Rudolf Christian Carl Diesel, the inventor of the diesel engine or the compression ignition engine. Again, not the inventor of CI engine, but an efficient CI engine that could be commercialized by the MAN trucks, right, in Germany. Henry Ford, American innovator, the one who initiated the modern assembly line, and of course the iconic Ford Model T car that was considered those days as the people's car. Orville and Wilbur Wright, even though they are two different people, I put them in as one because they basically are known for the same work and did it all together. The Wright brothers, as they are called. Again, not the inventor of powered flights, but the first reliable manned powered flight. Okay, once again, that created the opportunity for what we see today as widespread the civilian travel as well as, of course, strategic applications. Last but not the least, Soichiro Honda. Honda, the only Asian in this list, was a Japanese engineer whose motorcycles beat Harley Davidson in the US. So I would like to share one story of Soichiro Honda. Honda was not particularly interested with the formal education that the schools would offer those days. He ran away from his family, went to Tokyo, joined a motorcycle factory, car factory, I think, to start with, and then motorcycle factory to train as a mechanic. And then he went on and of course, to cut a long story short, started his own company. At the time when the Japanese motorcycles were nowhere to be seen in the US, Honda, and of course they were not as good as many of the other motorcycles that were reigning the market. He claimed the following. There was a competition of motorcycle racing competition. And he said, next year, Honda is going to win this championship. And he put together some of his finest engineers and asked them to design the motorcycle that would win this championship. Of course, nobody believed him, but then everybody got curious and they started looking very keenly on the development that this Japanese team had done. And for a year, they were very closely looked at. Eventually, the competition happened, and Honda's teams by motorcycle did not win the competition. However, it turns out in retrospect that was not what Honda was interested in. He was interested in making sure that the entire US knows what Honda is. And of course, that purpose was fully served. It was well known by then because of this atrocious claim of audacious claim of them winning the championship. And the following year down the line, Honda launched its first motorcycle in the American market. And because of the publicity that they had received earlier, it was a far more acceptable name than it would have been otherwise. Over a period of time, it was able to make a much greater market share of even the US market than, as I said, Harley Davidson did. So I think there is not much doubt about the quality of these inventors and innovators, and we can of course increase the size, but let me just tell you what was found when an analysis of their lives were made. So one wanted to see what the common traits were among these individuals, and some traits really stood out. The first was the diverse interest and the high levels of curiosity. It was without exception that all of these people is incredibly curious. They're not just interested in what their syllabus told them to read, right? They wrote widely, well beyond that. For instance, Diesel was interested not only in heat engines, and of course, he was from Munich, and he was working for a professor's company called Linde that was making refrigerators. And he made some major changes in the way in which heat engines would work for refrigeration. But then he was interested in chemistry, he was interested in art, languages, social theory, and so on. In fact, he had said at that time, and we are talking about 100 years ago, that there is no reason why diesel engines should not use biofuel. Um, and it's being slowly inducted into diesel engines now. Second was that they were not only just curious, they were also interested in solve problems, achieve goals, apply principles. They were highly perseverant. Okay, they were never shy of hard work. They were not impatient. They were incredibly patient. And they also had a lot of self-belief, a lot of positive attitude. They would not take a failure ever. They will just move on and keep trying. They had a very high standard. They were not easily satisfied. It's easy to succeed if you have a very low standard, right? It's fine. If I get 50 marks out of 100, I would consider that my success, and then most of the people would be successful. But if somebody puts and saying, I need to have at least 95 marks before I consider myself successful, then obviously that's going to be far more difficult and therefore much harder to achieve. But then that's what they were. They were very keen on action. They're always active. And they were learning all the time. They had been students of lifelong learning university. Once again, I will share a story of Honda. So Honda was the CEO of his company. And at that point of time, they were making bearings, right? For those who do not know what a bearing is, okay, bearings are parts where you can attach something that is moving, rotating in fact, with something that is static, okay, that is not moving. This is a common situation, right? Many times in a machine will have a shaft, right, a cylinder, and that cylinder will rotate, right? Why would it rotate? Because you transfer power from one side to the other. So when it is transferring power and it's rotating in mid-air, somebody has to hold it, right? Now, this somebody has to hold it in a manner that allows the rotation to continue, and yet it should not fall. So it has to be held like that. So how do you make a part that will hold something without stopping its movement? And that's what a bearing is for, right? So he was making bearings. And he took an order from the company, the other company, the motor car manufacturing company called Toyota. So Toyota gave an order to Honda to make bearings for its some parts of the car. So Honda's company made all the bearings. They supplied it to this company, and every single one got rejected. Why? Because they're not of the right quality. Okay, they were not of the right quality as expected. So Honda, obviously it was a loss, physical loss in terms of money and so on, but far more importantly, it was the company's reputation that was at stake. So then Honda had to do something. So what he decided was something novel. He actually took up a master's studentship in the evening in a university in Japan. And the master's program was on material science. So he wanted to understand material science good enough that he could apply that knowledge in order to see what was wrong with the way in which they were making the bearings that led to their being rejected. And it went on like that for his entire program. He solved the problem. The bearing was improved. And when the next order was placed and they sent their bearings, every single one got accepted. So this is how these people were. They were learning through their life. They also had a healthy suspicion and questions for accepted wisdom, right? And they worked on that. They also had a wider repertoire of knowledge, not only knowledge as we understand from books, which are what one would call validated domain knowledge, but also hands-on skills, right? For example, James Watt was at his time one of the finest makers of precision instruments like a microscope or a telescope. Isambard Kingdom Brunel learned how to make precision watches and clocks under a very well-known horologist, clockmaker, right, in Paris for 5 years before his father, who was also a railway engineer, brought him back to say, you are ready now to operate as a professional. So they all had hands-on knowledge. They could try out their ideas and see whether they worked on their own. And the third kind of knowledge, the imagination and the intuition, is also something that they had in abundance. So the variety of knowledge that they brought to bear in their problems were manifold. The last, of course, was that they all had, at some point or the other, an environment that supported them. And maybe this is a fallout of the other traits that we saw. So it's not exactly their trait, but it's more like a factor that they all had. I deliberately highlighted 2 of these 10 traits or factors. One is perseverance and the other is high standard. Now, why did I do that? Because they sort of are contradictory, or they kind of